Now that we understand how to apply draft at the sketch level for things like a revolved part, or at the feature level for things like our extrude, let's talk about applying draft after a feature. Again, we'll start by creating a new file using our drafted template, sketch on the top plane, and again, we're going to create a center point rectangle. It's going to be 5 inches tall, 10 inches wide, and we want to extrude it up 5 inches. Now in this case, we're not going to select draft. We're going to say OK, and we're going to apply draft after the fact. Now, there are several times where it makes more sense to apply draft inside of the properties of the feature. There are also times when it makes more sense to apply draft after the fact. You do have to be careful when you're dealing with drafted parts because things like features, for instance, if we were going to cut a hole through the side of this part, let's go ahead and sketch on the front plane, draw a circle, and do an extrude cut through the part. We'll go ahead and say through both directions. Now in this case, we could go ahead and draft the outside of this part, we could do a shell, and we would be able to create the part just as we wanted. But if this hole needed to align with a drafted face, you would want to be careful in using standard planes because then the direction would not be correct. So in this case, let's go ahead and delete cut extrude 1, delete the associated sketch, and let's start drafting this part. In order to draft this after the fact, we're going to go to our Features tab to the third section and select Draft. Now there are two main options when you come in here, Draft Expert and Manual. Now Draft Expert uses only the neutral plane type of draft, and it just basically gives SOLIDWORKS a way to help organize and handle how the features are propagated. In this case, we're not going to talk about Draft Expert. Under types of draft, we have neutral plane, parting line, and step draft. Step draft is a variation of parting line that deals with a very specific instance. In this video series, we're only going to talk about neutral plane and parting line. Let's start by using neutral plane. Under draft angle, we're going to use the equal key and set it equal to the global variable draft and say OK. For our neutral plane, we can select faces, such as the top of the part, or we can expand our tree and we can select planes. Now, depending on your selection process, where the plane is, and the direction you're pulling, you might get different results. For instance, if we were using our neutral plane as the top plane, we're pulling from here, the outside faces are going to be drafted inward. If we selected the top face of our part, we're pulling from here and we selected the opposite direction, it would be drafting downward toward the top plane. So using even a very similar selection set, you can get two different results. Now under faces to draft, you'll notice below this, we have face propagation option. Now, I'm not going to talk too much about face propagation, and really it's because it's a little buggy. Sometimes it works, sometimes it doesn't based on your geometry. So I don't want you to rely on using the face propagation inside of the draft feature. I want you to be able to manually select the faces that you want to draft and not have to rely on this feature. So let's go ahead and minimize that and let's start selecting faces. I'm going to select the front face, the side face, and then I'm going to right click and go to select other, and that allows me to select the back face and the left face. Now, SOLIDWORKS 2016 has offered a nice option. The small dot below the selection box allows you to move it up and down and gain as much or as little room as you need for your selection. Now, in the past, it was only set to about 3 or 4 of these wide, so you had to scroll up and down, especially if you had many selections and you were trying to find a specific one. So 2016 is very nice that we have this option now to drag this box up and down. Now that we have these 4 faces selected, you'll notice that the arrow in the direction of our neutral plane is pointing up. So we're going to draft these faces inward just as we did in our extrude option. So let's go ahead and select OK. Now I want to make a quick note. If we go back to draft 1 and we edit this feature, you'll notice that types of draft, if we change it to parting line, we have some different options here. We're still using the same direction of pull, but you can select a parting line that you want to draft from. Now, in this case, we're not going to get a different result, but I want to use the same selection process. We're going to go ahead and select the bottom edge, and you'll notice it comes in purple. Now, the reason that using the parting line option is very handy is essentially because it doesn't have to be a plane. It can go up and down around the part and give you a very unique way to apply different draft to these parts. You'll also notice that each individual edge can be changed direction. So you'll notice at edge 4, if I select other face, it changes the way that the draft is applied. Now you also can manually select the yellow arrow and change the way this is as well. Now, as we go through here, you'll notice that we also have allow reduced angle. So there are some other available options inside parting line that allow reduced angle depending on what the angle is and how close it is to 90. In this case, it doesn't really apply to us, so I'm not going to talk about it, but just note that there is another option. You can always select the help icon and go into the SOLIDWORKS help file and get more information about this specific dialog. So let's go ahead and choose the parting line and say OK. Now the result is exactly the same. And again, it's because we're using a very symmetric part. The bottom face is planar. But if it wasn't planar, you could use that parting line option and get a very unique result for applying your draft. Now, the next thing I want to talk about is what to do in terms of order of operation. In the last example, we drafted inside a boss extrude, then we applied some fillets, and then we shelled the part. So let's go ahead and apply a few fillets. We'll make 1/2 inch, and then let's shell the part. Now, the shell is going to be linked to our wall thickness. Let's go ahead and say OK, and link it to our global variable of wall thickness. And you see that we now have a shelled part. Now, whenever I'm dealing with applying draft as a feature, as opposed to doing it in the properties of the specific feature like a boss extrude, I typically make it a point to draft before fillets. SOLIDWORKS will allow you to draft after fillets, but the result can be very different. So let's take a look at this example. Now, what I want to do is make note of the fillets here. Now, they're fairly consistent. It stays the same radius value from bottom to top. But let's go ahead and roll the tree back before the shell, and I want to reorder this. I'm going to take draft and I'm going to drag it below fillet. Now you notice that instantly the result doesn't look very good. Now we've drafted the part after the fillet, but we haven't selected all the edges. So we have a filleted part, we go into draft and we modify this. We need to go back and we need to select these faces, or we can use the face propagation along tangent and say OK. Now, the note that I want to make here is the draft applied to the fillet actually reduced the fillet amount going up. So this outside of the part looks very different than the original example. So if you want to have a consistent fillet value from bottom to top, it's better to be applied from a squared edge part that's already drafted. If you apply the fillet and then draft, you're going to get a very different result than if you apply the draft and then the fillet. So hopefully that made sense. It's a little bit tricky and you really should just play with examples on your own, figure out how it works for you, and that's going to be the best way to understand the way that the draft feature works. Now, draft feature doesn't have to be applied to the entire outside of a part. Let's go ahead and roll this all the way back before the fillet, and let's apply draft one more time. Let's go back to neutral plane. For my neutral plane, I'm going to select the top plane, and for faces to draft, I'm simply going to select the right face and the left face. I'm going to manually enter a large draft angle of 15 degrees and say OK. So in this example, it's drafted the two outside faces. If I look at from the top, the front and back don't have any draft applied. So when you're applying a draft feature, you don't have to draft all of the walls, and that's probably the biggest benefit. When you're doing it inside of a boss extrude, all of the walls are drafted exact same all the time. Using the draft feature gives you the flexibility to apply a certain amount of draft to one face or multiple faces and not the entire model. So that's, in a nutshell, the ways that you can apply draft to your part. Of course, there are many other ways that we can handle it. You can do this as surfaces by doing extruded surfaces and helping by setting the draft at the base and allowing the shape to sort of make the organic transitions. You can do it from the sketch level by doing things like giving extrudes directions and tapers, or giving lofts the directions and tapers they need by using guide curves. But for the most part, especially when you start designing your parts, you want to use draft inside of your features or draft after the fact, and those are going to be the two most consistent ways.